Ever wondered how a simple business question, something someone says in a meeting, turns into one of those powerful dashboards that actually drives decisions? Well, today we're going to pull back the curtain and look at the entire life of a data project. We're talking from that first little spark of an idea all the way to a finished tool that's spitting out real insights.
So how does it happen? That's the big question we're tackling today. We're going to follow this whole journey, starting from a really vague business need, something like, hey, we just need better visibility into our fleet, and see how that evolves, step by step, into an interactive tool that gives you those crystal clear insights. It's a really cool process, honestly, where business strategy and some pretty deep tech have to come together.
All right, so here's our roadmap for this explainer. We've got 5 main stops. First, we'll look at how you go from a raw idea to a solid requirement. Then we'll dive into the data pipeline, the real engine room. After that, we'll see how to build a data skeleton to make sense of it all. Then the fun part, telling stories with dashboards. And finally, we'll get real about what happens when things don't go exactly to plan.
Okay, first things first. You have to turn that fuzzy business need into a rock-solid plan. And let me tell you, this stage is absolutely critical. Seriously, if you mess this part up, the whole project is basically built on quicksand. It's all about nailing down the what and the why before anyone even starts thinking about the how.
So a huge part of that is understanding the difference between these two things, a BRD and an FRD. The Business Requirements Document, the BRD, that's for the business folks. It's high level, it's the big picture goal, like we need to improve our fleet visibility. Simple enough, right? But then you've got the Functional Requirements Document, the FRD. This is for the tech team. It gets super specific. It translates that big goal into concrete rules, like, okay, if a truck is idle for more than 15 minutes, we need to flag that as a delay. See the difference? One is the dream, the other is the actual blueprint to build it.
So how do you actually get that blueprint built? Well, it's not just guesswork. It's a really clear 4-step process. You start by just talking to people. You run workshops, you do interviews, and you really dig in to understand what their problems are. Then you write it all down, clearly. But here's the key part. You take that document back to them to make sure you got it right. And finally, you have to prioritize. Look, you can't do everything at once, right? So you have to figure out what's going to deliver the most bang for the buck and start there.
Okay, so we've got our requirements locked down. We know what we need to build, but where's the data for all this going to come from? And that question leads us right into the engine room of the whole operation, the data pipeline. And at the heart of that pipeline is a 3-letter acronym you hear all the time, ETL. It stands for extract, transform, and load. The easiest way to think about it is like a data refinery. You're taking in all this raw, messy, kind of useless data from a bunch of different places. The ETL process cleans it, standardizes it, and gets it all shiny and ready for analysis before loading it into one central spot. You know the saying, garbage in, garbage out? Well, good ETL is what prevents that from happening.
So let's break that down. First is extract. This is literally just pulling the raw data from its source. Think GPS logs from trucks, return requests from your sales system, whatever. Then comes transform. This is where all the real work happens. It's kind of the magic step. You're cleaning things up, filtering out junk, maybe merging a few different data sets together. And once it's all clean and tidy, you load it into your data warehouse, where it's ready to go for the next stage.
So what's in the toolbox for this kind of work? Well, Python is king here, mostly because it has these amazing libraries that make life so much easier. You've got Pandas, which is the absolute workhorse for all that data cleaning and manipulation. Then things like SQL Alchemy or PyODB, which help you connect to all sorts of databases. If you need to pull data from an API, the request library is your best friend. And to run this whole show automatically, that's where a tool like Airflow comes in, letting you schedule and manage the entire pipeline.
All right, so our clean, sparkling data is now sitting in the warehouse. We're done, right? Ha, not even close. Now we have to actually organize it. This step is like building the skeleton for your project. You're creating a solid structure so that when it comes time to ask questions of the data, it's fast, efficient, and just makes sense.
And a super common way to build that skeleton is with something called fact and dimension tables. Sounds complicated, but the idea is simple. Fact tables store your numbers, the things you measure, the events. So for our delivery example, that's stuff like distance traveled or how many minutes a delivery was delayed. Dimension tables, on the other hand, store the context, the who, what, where, when. So that's the driver's name, the route's origin and destination, the date. When you link them together, you can ask really powerful questions, like, show me the average delay time for all trips in the Northeast region last quarter. See how that works?
Okay, we've defined our goal, we've built our data pipeline, and we've structured everything perfectly.
Now we get to the payoff. This is the grand finale. It's time to take all that hard work humming away in the background and bring it to life, telling actual stories with the data through dashboards.
And look, this is not just about making pretty pictures. It's about making a real difference. By digging into GPS data and visualizing where the problems were, one project actually improved its real-time tracking reliability by 15%. That's a big deal. That means fewer lost trucks, more accurate ETAs, and ultimately, happier customers. That's what a good dashboard is all about.
So, what does a dashboard like this actually look like in practice? Well, here's a perfect example, a route compliance dashboard. Imagine you're a manager. You open this up and boom, right away you see your main KPI, on-time delivery percentage. You can look at an interactive map and see exactly where a truck went off route. You can spot your problem routes with a simple chart, and then, this is the cool part, you can filter it all down by a specific driver or region to find out why. It takes a massive amount of data and turns it into something you can actually use. But sometimes, the really mind-blowing insights aren't obvious. They're hidden. And to find them, you often need to combine your own data with data from the outside world. That's what this next example, the Weather Impact Dashboard, is all about. It's not just looking at internal trip data, it's layering in historical weather information to see if there are any hidden connections.
And what they found was pretty surprising. It turns out, right after mechanical failures, the number 2 cause of all delivery delays was weather. It accounted for almost a third of all their problems. Now, that's not just a hunch from a manager. That's a hard number backed by data. An insight like that is huge. It can justify spending money on better planning tools or new driver training. It's a story that was just sitting there in the data, waiting for someone to find.
Okay, so in a perfect world, the story would end there. We build the awesome dashboard, everyone loves it, and we ride off into the sunset. But we don't live in a perfect world, do we? The last and maybe most important piece of this puzzle is dealing with the messiness of a real project once it's out in the wild. Because trust me, the plan always changes. Sooner or later, this is going to happen. The dashboard is finally in the hands of the people who are going to use it every day. And they'll find things. Maybe something isn't working quite right, or maybe they get a brilliant idea for a new feature. How you deal with that feedback is honestly what makes or breaks a project in the long run.
And the absolute key here is to know the difference between a bug and a change request. They are not the same thing. A bug means something is broken. The distance calculation is wrong. That's a problem, and it needs to be fixed. But a change request is a new idea. It's someone saying, hey, you know what would be cool? An export to Excel button. That wasn't part of the original plan. If you don't treat these two things differently, you fall into the trap of scope creep, where the project just keeps growing and never actually finishes.
And this quote right here just nails it. You need a disciplined system. Bugs get logged and tracked in a tool like Jira, so nothing falls through the cracks. They get fixed. Change requests, on the other hand, are captured as new ideas for the future. This way, you can still be super responsive to what your users want, but you do it in a controlled way that doesn't completely derail the project.
So when you really think about it, a dashboard is never just a chart. It's the final chapter of a pretty long story. A story that starts with a simple business question and goes through requirements, data engineering, and modeling. It's the very tip of a very large iceberg. And that really leaves us with the most important question of all, doesn't it? What story does your data need to tell?